So I was just watching some videos about some old computer systems, and got interested to see whether I can get some of my old ones. And I pulled out an XT clone, powered it up for a very short second, turned it off, just a quick switch on and switch off, and it wouldn't switch on again. So getting this XT compatible up has turned into a bit of a part swapping affair. So first of all, I switched it on for a couple of seconds and switched it off. The hard drive came up. There was no bangs or anything like that. Switched it on after about 10-15 seconds. Power supply wouldn't come up. Opened the power supply up, saw the rectifying, the high speed diodes, or I'm not sure which rail it was ajar, so I soldered those, and then I thought I would measure these, and at the time they measured bad, so I replaced these Tizon reservoir caps with some Rubicons, which had tested good ESR. Plugged it in, still wouldn't power up. Wonderful. Pulled the whole board out, used my LCR meter to track it down to a shorted tantalum cap. Undamaged. Supposedly 25 volts rated, 4.7 microfarads. Tracked it down, just ohming it out. It was started off at like 80 milliohms, and then I just got lower and lower and lower down to like 40 something milliohms, and where I found this shorted. Replaced it from there, and then the one next to it blew up in a massive way. So it was a bit of a fireworks episode, and so it reinforces the fact that these tantalum capacitors, the board's riddled with them. So the yellow ones have all blown up so far. That one's a yellow one. We'll see whether that's going to go. There's another yellow one there. The blue tantalums so far haven't given me any trouble. Oh, and it was a dead memory chip as well. Unbelievable. I ended up, when I powered it up, it was just giving me an initial beep, like when you power it on, you get a short beep, but it went beep and then a really long beep, continuous beep. Plugged in my post-diagnostic card. Doesn't work on an XT. Obviously, the way that these post-diagnostic cards work is that the BIOS writes to port 80, I think, in hex. I'm not sure. I can't remember. It's been a long time since I had to do anything like this. And basically, this is just like a bunch of circuitry with registers and alerts it, and it displays what gets written, and then you look up what the codes are in that sort of stuff. But it clearly states that it only works. It's only 286, 386, 486 and 586 computers that will likely have the BIOS bits to write to that port, so you can look at your power on self-test codes. Anyway, but I managed to, what I did is I moved that row to there, and then it came up with 56k, and then I got some memory chips. They're actually slow, 150 nanoseconds, opposed to these ones which are 120. And I just worked my way through it and found the dud one there. Good fun. So we shall see if it blows. If another cap goes, that's it. I'm calling it a day. I'm not gonna bother trying getting it up and running. It was just a curio that I wanted to get going, because I haven't had this XT machine up in such a long time, and clearly, I mean, obviously, that wasn't the extent of the problems. There was also an issue with the integrated floppy serial and real-time clock. It obviously had one of those damn NiCads on it, and you can see. So, yes. Interesting enough that so the two tantalums there, the one on the left there, the left yellow one was the minus 12 volts, and the one on the right was the plus 12 volts. And the plus 12 volt one blew. I got the RAM going, got it to boot up to the point with the video card, complained about the floppy drive, plugged this in, started to look for the floppy drive, bang. So we shall see now what's going to happen. So let's get it all back to where it was, and at the very least we'll be able to capture any further explosions on video. Yeah, the graphics card. So anybody who's going to be working on XT style systems, a lot of peripherals can operate in an 8-bit slot, even though there are 16. See, that's an 8-bit slot. That's an 8-bit VGA graphics card, and so that works in an XT amazingly enough. Well, I suppose it's not amazing because the thing that gets it going is that BIOS, because it's just. I'm not sure whether I think I've tried a Trident 16-bit one in an 8-bit slot, and I think it worked. I can't remember. But it depends on the BIOS. I mean, if the more fancy the graphics card are, the less likely it's going to work in an 8-bit slot. But that's an 8-bit card. And there's an 8-bit Western Digital hard disk drive controller. So I'll leave that out for the moment. There's an example of a 16-bit card that will work in an 8-bit slot. That's just an old school Ethernet adapter with coaxial. That was in the machine and working. NE2000 compatible, using this UMC 9003 chipset. But anyway, that's plugged in, keyboard's in, graphics is on, monitor's on, floppy power is in, hard drive power is unplugged, and it's not the power supply. Initially, when I was doing some load testing with my dummy loads, the voltages were quite low, but since long before it was blowing up, when I was testing the memory, that was one of the first things I checked with that beeping was the supply rails, and they were bang on. So obviously, in the past, these old style power supplies needed a significant load on the 5-volt rail, and everything else was derived from that. The next round of power supplies, when they started going to 3.3, they transitioned, I should say, from the 5-volt rail to the 3.3 rail. So there's one rail on most power supplies that has to have a minimum load on it before the other rails will get regulation. So I suspect that was insufficient load on the 5-volt rail. Each one of those is 1.78 amps, so just under 4 amps. That should have been enough load on the 5-volt rail for it to get regulation, but clearly it's working better on the motherboard. So anyway. All right, time to get scared. Will there be an explosion? No more. No, there we go. Just so 640 kilobytes of memory. DTC Corporation. Urso PC BIOS version 2.0, version 3.23. Interesting. Well, rather than standing here and twiddling my thumbs, I will measure the supply rails yet again. Just give me a good earth off there. Fix the range. So the orange should be power good. 5 volts. Pretty much bang on. Yellow is 12 volts. 12.1. Blue is minus 12. 12.1. And the white should be minus 5. Yep, bang on. And 5 volts. Bang on. So all the supply rails are good. Just it's sitting there waiting for me to put in a bootable floppy and all that sort of stuff. I'm not going to do that because I've got to, well, I don't know. Theoretically it was bootable, but it's yeah, it's an MFM drive. So one of the first things I'm going to do to it is to do a reinitialize because on these things the hard disk controller actually writes all of the sector preamble and all of the stuff in and around your data, and what happens is that over time the magnetic field strength reduces, but it only rewrites all of the address marks, the sector marks and all that sort of stuff when you do a format. So what happens is you've got data on there, your addressing mark and your data have reduced in magnetic flux, so it can probably read it, but as soon as you write something, the data part becomes really large, and now the amplifier can't respond fast enough, and what's going to happen is you're not going to be able to read where your sector and address marks and all that sort of stuff, because it's going to get shouted at by the data you just wrote, and then you effectively make the drive useless. So the idea here is that before you do any writing to your hard drive, if something hasn't been done, there's a program, what was it called? SpeedStore, which has a reinit function, and what it does is it reads your data off and then writes your basically reformats the track and then puts the data back down. Now, there's a risk involved there because whilst that's all doing it within the track, and it works its way through the head, so it does the entire cylinder, each track has an adjacent track. And I don't think these drives are high enough density to cause a problem, but we shall see. All right, I think that's long enough. I'll hook the hard drive back up, and I won't let you watch that because it's pointless, but I shall return. Okay, got it together. This good failure. Well, look what I found. It's an alignment disc I wonder whether it still works. It's for lining floppy disk drives. 1.360K and 1.2 megabytes. Basically, what you can get the DDD, which is the digital diagnostic discs, as written in the label. Or you can get an analog disc. An analog disc, basically, you had to use an oscilloscope. And a digital diagnostics, you could just use the software, the Dyson software. But essentially what what Dyson did, is they used a special machine. With the analog disc, they run two like tracks off center, skew from where the center of the track should be, and that produces a capsule. In the digital diagnostics discs, what they do is I can't remember how many sectors it is, but what they do is you can imagine you've got all these tracks on your disc, but within where the specification for the track says it should be, like the measurement and all that kind of stuff, what they do is they use a machine which starts off, puts a sector here, and then moves in a little bit and puts a sector there, and puts a sector there, and puts a sector, and one of the sectors is a dead center of where the track should be, and then the next sector, etc. So that when you ran the diagnostic disc, it would produce a little graph showing you how many of those sectors which were off the center line. And no matter how many times I told various people that you needed special equipment to do that, I had people that would swear black and blue that they can go and get that, what was that called, copyright or something. It was a bit of hardware, and what it would do was it would read a sector in and copy the disk, and so they would use that to make a hardware, in quotes, copy of the digital diagnostics disc. And I'm telling them, no, that's not going to work, because you need to have those sectors offline. You know, like when you write the track, say your track is that wide, it's stepping sort of incrementally across the track width. And so what they've done at best in copying it is copied the sectors that the particular drive that they used to read the digital diagnostic disc, and then wrote those sectors out. But yes, I wonder whether these discs still work. I mean, I think that means that I can do 5¼ inch driver alignment still. I'm sure I've got a DDD for a 720K as well somewhere. Dip the heads of clay. What I wanted to do was to catch it so it would not only clean it sideways, but get the head movement, give it a good. This should work. Speed store, 1.2 meg. So I'll move the camera. It's loose. Maybe I should screw it in or something. Let's have a look at that hard disk. So it's already configured for a 20 megabyte. trying to remember how it works again. Diagnostics. It's been ages since I've actually ran this program. Decades. Definitely don't do any writing because I want to try and it's doing a recal. Okay. Okay. It's definitely got stuff on the C drive. So let's do a reinitialize, and then I'll fix it up and get it to boot, do a sys on it and all that kind of stuff. So we'll do diagnostics. We want to do, no, we don't want to do diagnostics, we want to do manual setup. We want to initialize, and we want to do the reinitialize. Oh, good question. I can't remember what the interleave was. It might be the default. I think it's 2. See how fast it is, and it'll give me an idea of what interleave it was. There was no transfer. Let me take it out of turbo. What the hell? Ay, ay, ay. Oh, maybe that was the problem. Okay, so it was the turbo that was. So that'd be interleave 3, I'd say. Interesting. Turn the turbo back on again. Oh, it's ready this time. Unrelated. Pretty sure interleave 2 was 200. Question here is the controller fast enough? Because it's the 8-bit one, not the 16-bit one. For 16-bit, yeah, I'm pretty sure. I think that's 2. I think that's 2. So that'd be right for about an 8-bit, I reckon. So. Interleave is when you're writing, you got your disk spinning around, right, and your heads move across the disk. Your disk is on each platter has a track, and within a track you have sectors, right? So each sector will have like your address marks and byte order mark. It's a whole pile of like a header, like I suppose you could talk about, in front of it, and then your payload, right? And then for every sector you've got your little address marks and stuff again, and then you've got your next sector. So what interleaving does, instead of putting sector 1 here and sector 2 here and sector 3 here and sector 4 there and sector 5, what happens is when you read, you typically read in a sector, then you process it, and the disk is still spinning at the time, right? And so by the time you get back to process the next one, the head's missed the next sector. So the idea here is that you interleave so that you have sector 0, then you have a different sector, and then you have sector 1, and then a different sector, and then sector 2, right? That's an interleave of 2. So what that means is that you don't have to wait for the sector to come around again, right, for you to pick it up and read it, right? And that's what interleaving is. And so the original IBM on the XTs, they had an interleave of 5. So what that meant was you read a sector, the 1, 2, 3, 4, 5, that was sector 1, 1, 2, 3, 4, 5, that was sector 2, etc. Right? What it is you're tuning it to try and get the best performance, but you don't want to over-tune it, because if you over-tune it, because you now got to wait for a full disk rotation and a bit for that sector to come round again. And you'll set up initialize, reinitialize, default cylinders, default heads. Let's do 2. And I'll leave that running and come back to it later.